Hi everyone, thank you for joining. So in this video we're going to solve another interesting integer equations. So x and y are integers and they are non-zero integers. This is a question from USA Maths Olympiad. So if you like to pause the video and try it yourself first, then we could go over it together. Right, so let's start by expanding these brackets. So we have x cubed plus x squared y squared plus yx plus y cubed is equal to x cubed minus 3x squared y plus 3xy squared minus y cubed. Right? We can get rid of x cubed. Now we know that these x and y are non-zero, so we can divide everything by y. So we get rid of that becomes square, that becomes 1, and that becomes a square, right? Okay, so let's put everything on one side. So we have x squared y plus x plus y squared plus 3x squared minus 3xy plus y squared is equal to 0, right? So we can rewrite this as 2y squared, getting rid of these two here, and then plus x squared minus 3x into y plus 3x squared plus x is equal to 0. Now what we have here is that we have a quadratic in y, right? So this equation will have integer solutions if and only if the discriminant of this equation is a perfect square, so that we don't deal with radicals. Yeah. So we're interested in the discriminant of this quadratic equation. So let's have a look at the discriminant. What is it? We have b squared minus 4ac, right? So that means we have x squared minus 3x squared minus 4ac. But let's simplify this. If we expand, we get x to the 4 minus 6x cubed plus 9x squared minus 24x squared minus 8x, right? Okay, let's simplify it. So we have x to the 4 minus 6x cubed minus 15x squared minus 8x. And let's factorize it. X into x cubed minus 6x squared minus 15x minus 8. If you look at the polynomial inside the bracket, one of the solutions are obviously x is equal to minus 1, right? Because if x is minus 1, what have we got there? We have minus 1 minus 6 plus 15 minus x, which gives us 0. That solves the equation. Yeah. We can factorize this further now, since x is equal to minus 1 is a solution. That means we have x plus 1 into x squared plus bx plus c must be identical to x cubed minus 6x squared minus 15x minus 8, right? So if we expand the left-hand side, we have x cubed. Now we're going to have bx squared plus x squared. So in other words, bx squared plus x squared, right? And then we will have cx plus bx, right? X, b plus c, in other words, yeah? And then plus c, right? Okay, so, and that's identical to this polynomial here. We can simply compare it. That implies b plus b must equal to minus 6. Simply comparing the coefficients. Okay, so b must equal to minus 7, and you can see that c must equal to minus 8, right? So in other words, we have x plus 1 into x squared minus 7x minus 8, and we can factorize that further. So that would be x plus 1, x minus 8. Right? In other words, that cubic equation boils down to x plus 1 squared to x minus 8. Okay? So, and we're multiplying that by x here. So we're going from there to there. Okay? And for this equation to have an integral solution, this number, discriminant, must be a perfect squared, right? But we already have x plus 1 squared there. So all we need is actually x into x minus 8 to be a perfect squared. And for that to be a perfect squared, we just say let that equal to z squared, right? And if we expand this, we have x squared minus 8x is equal to z squared, which can be written as x minus 4 squared minus, well, we will have now the first two terms, but we will also have plus 16, so we have to subtract minus 16, is equal to z squared. That implies x minus 4 squared minus z squared is equal to 16. So if you notice that this is difference of squares, so we have a squared minus b squared, we will write it as a minus b times a plus b. Okay, so a minus b would be x minus 4 minus z, and then we have x minus 4 plus z, right? And that's equal to 16, right? Okay, so integer equations, again, what are the possibilities? Well, if you think about it, if you write it this way, it might be more easy to see. X minus z minus 4 into x plus z minus 4. So it's an integer equation. In other words, we need to look at the factors of 16, but we don't have to consider every factor, because if you notice that this bracket here will always be greater or equal to this bracket here. So in other words, we want to use the bigger number on the right hand side. So it could be 1 times 16 minus 16 minus 1, or 2 8, or minus 8 minus 2. And then exceptional case, if z is 0, we will have 4 4 or minus 4 minus 4, that they can be equal. Okay, now we need to test all these possibilities. For 1 and 16, we will have x minus 4. For 1 and 16, we will have x minus z minus 4 is equal to 1, x plus z minus 4 is equal to 16. Okay, and if we add the two, we will have 2x minus 8 is equal to, now what would that equal to? 17. But x has to be a non-zero integer. This will not give you an integer, because we will have 2x is equal to 25. X is not an integer, right? So we ignore this. This is not a solution, all right? Let me use the same table, because we're going to do the same thing over and over again. So now this time we have minus 16 here, minus 1 there. Now if we add the two, we're going to get minus 16 minus plus minus 1, which is minus 17. Again, this is going to give us an odd number, and odd number divided by 2, x will not be an integer. So this is not a solution either, right? Now let's have a look at the next one. Next one is 2 and 8. So this is 2, this is 8. Now if we add the 2, we get 10 here. So 2x is equal to 18, x is equal to 9. So that's one solution here. And I'm going to write here, so let me write it as xy. So x is 9. We don't know what y is, right? Okay. We will work that out. So let's go back to the table. So we had a solution there. And then now we look at the minus 8 here, minus 2 there. If we add the 2, we get minus 10. That means we have 2x is equal to minus 10 plus 8, which gives us minus 2. So x is equal to minus 1, the other possibility, right? Okay, so we had a solution there as well. So the next task is to try the next possible solution. So 4, 4, if we add them, we get 8. So we have 2x is equal to 16, x is equal to 8. So we have another solution. And the last possibility, minus 4, we're going to get x to be 0, but question tells us x is a non-zero number, so non-zero integer, so we're not going to get solution there either. Now all we have to do is find the corresponding y values. To find the corresponding y values, now we use the quadratic equation from the previous part of the question. So using quadratic formula, we have y is equal to minus b, which is minus x squared minus 3x, plus minus square root of b squared, which is x squared minus 3x squared, minus 4ac, well, 4 times 2 times c, that is 8 into 3x squared plus x, right? And we divide all that by a, 2a, which is 4. Okay, so in other words, when x is, let's start with 9. So when x is 9, we have y is equal to. Okay, so if you plug in the values, this is what you get. In other words, y is equal to minus 54 plus minus, well, 2916, take away 2016 is 900, and square root of 900 is 30, so we have 4. That means y is equal to either minus 24 over 4, which is minus 6, or y is equal to a minus 84 over 4, which is equal to 21, minus 21, okay? So minus 6 and minus 21. So we have minus 6 here, or we have minus 21. Okay, right. Okay, so the next possible solution is what x is equal to minus 1. So if you plug that in to this equation, I'll just do it quickly here. So we have minus, if x is minus 1, you will have 1 plus 3, which is 4, plus minus square root of, so we have 4 squared, which is 16, minus 8 times, well, if x is minus 1, 3x squared plus x will give you 2. So we have that, and we divide that by 4. So that's equal to, well, 16 minus 16 is 0. So we have minus 4 over 4, which is equal to minus 1, right? So when x is minus 1, y is minus 1. And when x is 8, we're going to get y is minus 10. I will leave that to you to check and verify, okay? So these are the solutions to this equation. Okay, so we found the solution to this equation, solutions to this equation. I hope you found it interesting. I hope you found it challenging. Thank you very much for joining. I look forward to seeing you in my future videos. Thank you.